Welcome to SolidChem Professor. I'm Sydney, your SolidChem Professor, and in this session we'll talk about HSM's option of 3D constant step-over. On this particular part, we'd like to show the use of 3D constant step-over. One of the major advantages of 3D constant step-over is that the step-over on the part is actually done according to the conditions of the surface itself. It'll be an even step-over on the surface itself. Let's take a look at exactly what we're talking about within the operation itself. And I'll start the operation of HSM, and I'll use the option, like I said, 3D constant step-over. Now, the tool that I will be using will be a 6mm ball and mill. And now we'll go into our drive boundary, which is an important factor in this particular operation. The drive boundary, what the drive boundary actually does, it lets us know exactly what will be the shape of the tool path itself. If I were to take a look at the part itself, I can have it say, choose the radius, this circle over here, as my drive boundary, and then the way it will work over the part itself will be in a circular fashion. It'll start working off in a circular fashion. If I was to take, for example, this area over here, the actual shape of this mouse over here, then this tool path will actually have a shape of the mouse itself. Let's first start, and we'll use the option of using our circular tool path as shown over here. And I'll use my working area as external, and my constraint boundaries will be, I'll also use create manually, and in this particular case I'll use this area around the mouse itself to be my constraint boundaries. In other words, I'm going to have a circular tool path, but it will only go up until the edge of that mouse itself, and again I'll use the option of external. Now, if I go into my passes area, I'll use, in this particular case, my step over of 1mm, and in my link, I'll use the option of bidirectional. Now, let's take a look at my simulation after I do my calculation of the part itself, and we'll note that the tool path is going in a circular fashion around the part, and as it gets down towards the edge of the part, it'll then finish off in the shape of the mouse itself. But note, in the beginning it started off with a circular fashion. Now, I'll go back into the operation itself, and what I'll do is I'll actually change now my drive boundaries, and it will be the exact same as my constraint boundaries. In other words, now the shape of my tool path will be the exact shape of the area itself, as we'll see when I do my simulation. Now when I do my simulation, after I do my calculation, you'll note that the tool path is the exact shape of the mouse itself all the way down, and you'll also note that the step over on the part itself is exactly even according to the condition, the surface condition of the part itself, giving us an equal and a very smooth finish of the part. Thank you for joining us on SolidChem Professor. Take care and have a nice day.